Good. All right, we're jumping into chapter 15, the autonomic nervous system. And if you had to give a definition, so talking briefly, so I didn't even mention about the answers to this quiz that I just gave you as the pre-lab piece, right? Things that the autonomic nervous system does. It's these automatic kind of things, right? So regulating your heartbeat or your blood pressure or controlling the glands that secrete different. Is that locked still? Oh, I'll unlock it for you. I'll unlock it. Digestion. That's what the autonomic nervous system does. What is the fight or flight reflex? This is part of the sympathetic nervous system, right? That it controls your action. It's getting you ready to perform some sort of action. Whether it is fighting that person, like Diana who's attacking you with her lotion, or you're just going to run away, because the smell just overwhelms you and you can't handle it and you run, right? So that would be fight or flight. And then the opposite of that sympathetic nervous system, the part that calms you down, it's like the Josh sitting next to you like, no, it's cool, man. Just relax, it's good. Don't throw the lotion, man. It's good. That would be the parasympathetic, right? Parasympathetic. Good. Though it's probably more the other way. I don't know. Anyway, we'll let that one go. So, autonomic nervous system. You see the definition there on the top of your study guide, that it is the motor nervous system. And that's a key piece. This is motor, right? This is an effector. It's causing an effect. It's not taking in. It's not sensory. It's effective. That's controlling glands, cardiac muscles, smooth muscles. And here's the key word. To maintain what? Homeostasis. Okay? Briefly, just pop over really quickly over to page in your textbook, page number 567. It's table 15.5. I don't know if they have it on here because it would be very large to try and put into one slide. 15.5, do you see it? What this is basically in one chart what the autonomic nervous system does. Its effect on all these different organs. And can you see that it's basically a balancing act? The whole entire autonomic nervous system is a balancing act. Yeah, there is nothing on here that shows this, which is what I expected. This is 15.5, the table, on page 567. So you have the sympathetic nervous system working, and you have the parasympathetic. And they just have this balancing act of back and forth. And that's what keeps you in this homeostasis. And again, we'll talk much more about that piece as we're going to spend time with in our second class period today. So the autonomic nervous system is also called the visceral motor system. And again, that motor's key, right? You're doing, it's an effector. It's not a sensory piece. And these actions are carried out involuntarily, without awareness, without you actually consciously saying, hey, do this. It just does it, right? It's keeping these background, if you want to say that, like the background activities of our bodies going, right? And these effectors don't depend on the autonomic system to function. So in other words, if we cut that sympathetic nervous system like we talked about yesterday, with the little mice that they had to keep warm and safe, right? They can still live. But they can't adjust their activity now, right? If they get too hot or they get too stressed, it kills them. Does that make sense? So it's that adjustment piece. So let's talk about visceral reflexes to begin with. And you already know what reflexes are, right? We did this whole section on the somatic reflexes, right? Where we had elbows moving and knees kicking and toes splaying, right? But these are visceral reflexes. So these are actually reflexes that happen in the organs or the visceral parts of our bodies. And again, to define a reflex, it's this unconscious, automatic, stereotyped response to a stimulation. I'm sorry? Sure, that would be one of them. Absolutely. Yeah. So these reflexes have this arc, which you already learned. We've already talked about this. This arc of a receptor that detects something. Excuse me. And in the visceral sense, we're talking about it detecting stretch of a blood vessel, or tissue damage, or blood chemicals being out of whack, or body temperature being too high or too low. This is the stimulus that causes this reflex. That afferent neuron then takes it up to the central nervous system. There's an integrating center, there's interneurons that are in the central nervous system that then send a response down the effector neurons. And then that effector neuron gets to some effector to actually make something happen. So they have a great example here. That's there on page 556, showing you an example of an autonomic reflex arc, this visceral reflex arc. So they're using what's called the baro reflex. Baro, does anyone know what baro means? What's a barometer? What does that measure? Not wind speed, air pressure. Yeah, pressure, air pressure. So this is pressure, a pressure reflex, a pressure from your heart. So the baroreceptors note that there are increased blood pressure. Baroreceptors are in that aorta. That's the vessels that come right off the aorta. This is the carotid going up to the brain here. They sense an increase in blood pressure, right? So they send a signal up the glossopharyngeal nerve to the medulla oblongata to say, hey, blood pressure's too high. Medulla oblongata says, okay, let's send down on the vagus nerve to the cardiac pacemaker, the piece of the heart that regulates how fast and how often it's beating, and tells it, hey, yo, slow down, let's calm down, right? It inhibits that pacemaker. So what happens? What's the effect that comes of that? The heart rate decreases, the blood pressure drops. Are you with me? And none of that happens consciously, right? Nobody comes and puts a hammer to the heart and goes, okay, stop being so high blood pressure. No, it just happens, right, from this stimuli that was the change in pressure. Does that make sense? And there are lots of these. There's a whole group of these different reflexes. As a matter of fact, we would talk about your digestive system actually has its own whole set of nerves and nervous tissue and reflexes for digestion. It's quite impressive, which I honestly didn't know much about until I was preparing for this chapter. Two big divisions of the autonomic nervous system. You've already guessed them because we've talked about them already. Sympathetic and parasympathetic. And this section that we'll talk about today is basically going through these different pieces and understanding how they work, the anatomy behind them, etc. So, in general, parasympathetic and sympathetic both go to the same organ. Okay? Because remember, it's a balancing act. Right? So if I got more sympathetic, I got less parasympathetic. But other times I want more parasympathetic and less sympathetic. So they're both affecting a single target organ, and they're just in balance with each other. Sometimes one more than the other. So the sympathetic, like I said, prepares the body for physical activity. So exercise, trauma, arousal, competition, anger, fear. And it does all the things to let you be able to do that by increasing your heart rate, increasing your blood pressure, increasing the amount of air you're breathing in, increasing your blood glucose level so you got lots of energy to actually run or fight, right? This is what's happening. At the same time, it cuts off blood flow to the skin, to the digestive system, because you don't really need to digest your food in order to fight Cammy, right? Camellia, right? You don't need that. Right? I don't need to digest. I need muscles, right? Because she'll take me down. Does that make sense? Or maybe just spike a volleyball really hard at me. I don't know. One of the two. Absolutely. Sure. Right. These are all pieces. Right. They go along with that. Absolutely. Yes, sir. Is it what? Sorry. Oh, sure. Yes. Definitely. Yes. So we're talking more about the act of digesting the food is where it's saying that it would reduce blood flow to that area. If she's talking about being very nervous or very anxious, and that's the preparation, that's a different sort of something. So yeah, there'll still be the ability to do those things. But it's just the body's saying, hey, that's background right now. We don't need to digest food. Does that make sense? I'd rather use all my energy to prepare for that amazing volleyball serve that she's going to whack me with. Does that make sense? Parasympathetic, just the opposite. Okay? This is the calming the body functions. So I'm reducing the amount of energy expenditure. Okay? The muscles are not as tense and as fired up. Things are relaxed. And then at the same time, I'm increasing the bodily maintenance kind of stuff, the digestion and waste elimination. So it's all the stuff that you need to do to stay alive, right? But not to run away or fight. Does that make sense? So if you had to give a little tagline for both of these systems, the sympathetic is the fight or flight, right? I'm going to fight you or I'm going to run away. Whereas the parasympathetic is the resting and digesting. I'm cool, I'm chill, I'm dealing with my food, where we all kind of want to be on a nice holiday weekend, after Thanksgiving. We're resting and digesting, right? There is this piece of what we call autonomic tone, and this is just the background activity of these autonomic nervous system, of the sympathetic and parasympathetic. When you talk about somebody who has muscle tone, we're talking about the muscle just kind of stays contracted a bit. You realize that's what muscle tone is, right? We talked about this a bit in the muscular system, right? Ladies, when they say, I want to tone up my arms, right? What you're saying is, I want the muscles to stay contracted a little bit. I want to increase the amount of tension that's present there so that, they look better, right? The same thing is happening here in this autonomic nervous system, right? You have this little bit of activity that's always going. And it's just this balancing act between the sympathetic and the parasympathetic working on all the different systems that they interact with. Does that make sense? Question?
Does the flight of does that cause us to shiver when we're nervous? Or what causes us to shiver?
Yeah, this is an anxiety reaction. I agree. The muscles are just primed to do something, and so you get these little shakes, these little shiver pieces. Yeah, I would say that would be kind of sympathetic. Mm-hmm. Good, we're just zipping along here, guys. We're doing well. We've got autonomic output pathways that I want to mention here, because the signal has to travel from the preganglionic fiber to the autonomic ganglion and then to the postganglionic fiber to reach the target cell. So it's basically a train, right? So from the central nervous system, right, from the brainstem, we're sending a signal out, and then we have a synapse that happens. And those synapses are what we call ganglions. We've used this term a couple of different ways for different places in the nervous system. And then there is a postganglionic fiber that goes to whatever organ or whatever effector we're trying to affect, right? So you can see, like just going to a muscle, it was just from the cord directly to the muscle. But in the autonomic nervous system, you have this preganglionic fiber, and then here's the ganglion, right, the synapse, and then here's the postganglionic fiber. Does that make sense? So that's sympathetic up here, with a very short preganglionic and a very long postganglionic. And in the parasympathetic, it's the opposite. A long preganglionic fiber And then here's the synapse and just this wee little tiny post-synaptic fiber that moves over. Okay, we'll talk more about that as we're going. But the point is simply that there's not this direct connection between the brainstem or the control center and the effector. There are these ganglions that are in between, these synapses in between. Are you with me? Any questions so far? It's going to go quicker than I thought, to be honest, which is good. It's good. Again, there's not a ton. There's a lot. If you've read this chapter or gone through this chapter already, there's not oodles of information here. I mean, there's tons of pictures, which is good. We like pictures, right? All right, so let's talk about the actual anatomy piece. And we're starting with the sympathetic nervous system. So the sympathetic is also called the thoracolumbar division, thoracic and lumbar put together, because that's where it arises. It arises from the thoracic and the lumbar regions of the spinal cord. Like I mentioned a moment ago, long post-ganglionic fibers, got the hiccups, and short preganglionic fibers. So out of the spinal cord, or the brainstem, actually this is all coming from spinal cord, my apologies. Out of the spinal cord to the synapse is a short fiber. And then from the synapse to the effector is a long fiber. That's what we mean by pre and post ganglionic. And they give you more details about the levels that they actually leave out of. But the key piece here is that all of these fibers coming out of the spinal cord lead to what we call the sympathetic chain of ganglia, the paravertebral ganglia. And I think this is a great picture that shows this. This is on page 558. It's very nicely dissected. This is an actual human cadaver that you're seeing here. And this train, this little line right here, is the ganglionic chain. And it does kind of look like a chain, doesn't it? Just kind of working its way up, with branches coming off, right? You see where I'm speaking of, right? It kind of just runs right down the center of this picture here. The blood vessels are going horizontally, and this is just this vertical piece going right up and down. That is the chain ganglia. They show you a schematic on the next page over that shows you again. So the ganglia would be this yellow piece right here, right? Where little fibers coming out of the spinal cord, those are the preganglionic fibers. And then post-ganglionic long fibers going to all the different effectors, all the different places in the body, dealing with the eyes, your salivary glands, your nose, your lungs, your heart, the intestines, the uterus, the penis, the bladder, the kidneys, all of these things being affected by these sympathetic nervous systems. Does that make sense? We've got three ways that the sympathetic nervous system, these fibers leave the body. I'm just going to keep moving down because we've already discussed all these pieces. Three ways. And they're showing this here on your study guide. Three routes. The first is in the spinal nerves. The second is by sympathetic nerves, and the third is by splanchnic nerves, which is a term we've not heard before. So, the spinal nerve route, you all know what spinal nerves are, right? These are the nerves that are carrying the sensory and the motor pieces to the arms, right? All the somatic nervous system we've talked about. There is some sympathetic nervous fibers that kind of just piggyback on those nerves. And they follow the same route to these organs. Okay? Things like sweat glands, the piloerector muscles. What do those do? Do you remember? Yeah, goosebumps, right? That's what gives you goosebumps. And then the blood vessels of the skin and skeletal muscles. So again, the blood vessels that open up when you blush or that close when you get cold, right? These are affected by the sympathetic nervous system. And they basically tag team on the spinal nerve. Does that make sense? The second piece are the sympathetic nervous system route, the sympathetic nerve route. So in this one, these are the effectors that go to the head and the thoracic cavity. So other nerves leave by way of sympathetic nerves that extend to the heart, lungs, around the heart, lungs, esophagus, thoracic blood vessels. They go to the sweat and salivary and nasal glands. Again, those piloerector muscles, the blood vessels, the iris in your eye, right, that controls how much light comes in, right, your pupils, your iris, right? This changes, and this is, again, caused by these sympathetic nerves that are moving to those guys. You cool? And last but not least, you have the splanchnic nerves. And these guys go right through the sympathetic ganglia, that big chain, without actually doing any sort of synapsing. They're just one direct fiber that's going from the central nervous system to this effector. And so that's why they differentiate them from those sympathetic nerves, because those do have that synapse in the sympathetic ganglion, whereas these go directly there. So what do those control? Things in the abdominal pelvic cavity. So this diagram just kind of shows you the three different ways. Again, not interested that you know the diagram per se, but understanding that there are these multiple pathways that can be taken. Any questions there? Another piece about the, there's just more details about where these splanchnic nerves are going to. Have you heard of the solar plexus before? Right, you punch somebody in just the right spot, and you just take their breath away. This is a series of ganglia that are there. And by doing that, it just basically inhibits the diaphragm. The diaphragm that helps you breathe doesn't want to be able to contract and to work. Right. Does that make sense? And they call it the solar plexus because the way it actually looks, the ganglia is here, and then you have these nerves coming off of it, these post-ganglionic fibers, and it looks like a sun, like a sunshine, the rays coming off. Sir? Sure. Yeah, any of these tissue, like any other tissue, you could, absolutely. I suppose if you did it just right, somebody could die, right? Because you actually couldn't get those nerves, those muscles to work if you cut off the nerve supply to them. Yeah.
Wait, so where is that?
I don't know exactly.
Because sometimes, like, what happens when someone just gets the wind knocked out of them, like not being punched, like they're just like falling or something?
Right. So I mean, this would be a temporary piece where again, you've just kind of you've caused so much pressure in this area that things are like they need a chance to reset.
But if it's in the front and you fall, is somehow?
I always think of it being like here. I don't know. There wasn't anything here that gave me a solid piece there to quickly turn to and find that. If someone wants to look that one up for me, I would love to hear, because I honestly don't know exactly where. You're looking to knock somebody out, right? Just kind of punch them just right. I got you. I got to stay away from Carrie today, man. It's a violent front row today, I tell you. One of the other last big things about the sympathetic nervous system is what we call divergence. And no, we're not talking about the book series or the movies. Okay, we're talking about this branching out. So the thought behind divergence is that when one fiber is stimulated, because it's this whole chain of ganglia, right? Because when one fiber gets stimulated, some of that stimulation goes to other areas as well. Does that make sense? Like, if you were to tell Autumn something, the ideal is that more than likely the people that she hangs out with are going to hear about this. Not that Autumn would do this, because she's a good person. She wouldn't do that, right? But she's going to tell Alice. She's going to tell Carrie, and right? There's going to be some divergence of your secret. Are you with me? And that's sympathetic. Again, because of this, they're all connected in this chain ganglia. It's very easy for when one thing gets stimulated, all of the pieces to get stimulated. Does that make sense? Or let's say you have a big family. I come from a family of 4 boys. My mom really couldn't just come and say, you know, Nathan, here's a candy bar. You just have this candy bar just for you. Nobody else gets it. That would be pretty tough, right? My brothers would be like tearing me apart. No, give me part. I want some of that. Of course, I was bigger, so I'd still eat the candy bar myself. But, you know, the point being that when one gets stimulated, many of them do. Does that make sense? And you'll see in parasympathetic, it's just the opposite. It's pretty much a one-to-one. If one piece is stimulated, that's the only thing that gets stimulated in the parasympathetic. Are you with me? Do we need to stand up for a minute? So I know it's really good. Yeah, let's pause. I'll pause here for a moment. All right, we're jumping back in here with the adrenal glands. So we just talked about the sympathetic nervous system, that division. And you would think we'd go right to parasympathetic, but they're pausing for this little piece on the adrenal glands. So these are these glands. They're on both kidneys. They're on the very top surface, the superior pole, if you will, of the kidney, the north pole of the kidneys, right? They're kind of little hats that sit on top of the kidneys. And they're divided into 2 main sections. And they're really almost like 2 separate glands that just happen to be put together in one package. The outer surface is called the adrenal cortex, the outer layer. And that secretes steroid hormones. And again, we're going to talk way more about this once we get into the system with the hormones. That name is not coming to my mind really quickly. Thank you. What in the world? My brain. The endocrine system. We'll talk way more about that. But the piece I want you to be comfortable with, these steroid hormones. And the adrenal medulla, the inside part of the adrenal gland. And this is dealing with adrenaline and noradrenaline, or norepinephrine. Epinephrine and norepinephrine. These may be things you've heard before. These words talking about these different hormones. And again, we're going to talk about these in much more detail. The whole thing, the whole group, this epinephrine and norepinephrine, we call the catecholamines. Another one of those fun words to say to people because it makes you sound smart. Right? The catecholamines. We'll talk more about these guys. But the point is that this gland also has some effects on these target organs. Very similar to the autonomic nervous system, right? And the difference between hormones and nerves is that hormones take longer to kick in and they last longer, right? Not always necessarily hugely longer to kick in. It depends on how much is released, right? Think about when I, banged my foot and slapped my hands and yelled, and you were ready to fight or flight, right? You were ready to punch me. So that kicked in reasonably fast, but then there's that hormone release of adrenaline, right? And you were still, kind of shaky for a little bit after that, right? So this is the effect of that adrenal gland, right? That adrenaline being kicked in. That's that steroid here, right? This adrenaline at the bottom here. Does that make sense? So they toss this little adrenal gland in there just simply to say, hey, it does have, there's a line from your textbook here. The sympathetic nervous system and the adrenal medulla are so closely related in development and function that they are referred to collectively as the sympathoadrenal system. Like you can't separate out the adrenal gland and the sympathetic nervous system. Does that make sense? But I'm telling you, we will go into way more detail about those adrenal glands and the hormones that they're producing in the endocrine system. Just so you can see, this is where they are. Adrenal glands sitting right on top of the kidneys here. They are breaking it down by the different pieces. Here's the cortex, the pink area there, and the medulla, the inside. It's also covered with this adrenal capsule. They're zooming in to show you different parts of that suprarenal gland or the adrenal gland. All right, last piece for today. with me yakking at you. Well, sorry, 2 more pieces. The parasympathetic nervous system. And again, if all the things we talked about in the sympathetic, this is just the opposite now. Okay? So the parasympathetic, remember that the sympathetic was the thoracic and lumbar areas of the spinal cord is where it arises from. So what's left? If I got the middle pieces, thoracic and lumbar, what do I have left? The brain, cervical, and the sacral. Right? So these are the 2 areas that the parasympathetic arises from. So from certain cervical and cranial nerves and sacral nerves as well. And these are opposite. They have a long preganglionic fiber, right? So and it kind of makes sense because to get from the cervical or the brain all the way down to the visceral organs, they have to be a long journey, right? To get down there. So it's a long preganglionic and a short postganglionic. The ganglions for these happen almost right next to the organ they're going to. Does that make sense? Sometimes actually even in the organ itself. Your textbook talks about that. Just making sure I'm not forgetting anything. There is very little divergence from these things. Remember, divergence meaning one thing is stimulated and it goes to lots of other places. The parasympathetic is basically a one-to-one. If this effector is being targeted by this one parasympathetic fiber, it goes right to it. It doesn't do much hitting other areas. There's no chains, right? No chains rolling through. Very selective in its stimulation. You do have 4 cranial nerves that deal with this parasympathetic division. The oculomotor nerve, number 3, that helps to narrow the pupil and focus the lenses in your eyes. The facial nerve, your tears, your nasal and salivary glands, that these will kick in. Again, I don't consciously say, I think I need to have my nose run because I'm having a cold right now. No, it just does it, right? As a way to try and get rid of some of these things coming in. That's taken care of by the facial nerve, number 7. The glossopharyngeal, you have this parotid salivary gland that kicks in. And again, you don't even have to think about it. It's just you start thinking about food, or even you can think about just the smell of food, and suddenly you start salivating, right? This is, again, a parasympathetic response. The vagus nerve is another one, number 10. And this goes all the way down into the colon, all the way down into the large intestine from your brain, right? It's a long distance to get down there. It also deals with cardiac and pulmonary and esophageal plexuses that deal with those pieces, the heart, the lungs, and the esophagus. Here's a nice schematic showing you that parasympathetic nervous system and all the places it goes. Very large preganglionic. Here's the ganglions, little yellow guys, right? And very short postganglionic fibers. Last but not least for today is the enteric nervous system. Which this was something I had heard a little bit about, but I didn't really know much about until I was starting to go through this section in your textbook. This is the nervous system of the digestive tract. Wait, what, your digestion system has like its own nervous system? It does, truthfully. Okay, it doesn't come from the brainstem or the spinal cord. There's no central nervous system component. What does it take care of? All the glands, all the muscles that deal with digestion here. Sir? It does. Your heart is the same way. There is literally brain tissue in your heart, which we'll talk more about. Because again, the heart doesn't need the brain to beat. It has its own pacemaker, its own piece that stimulates when to beat. Yes?
Is that why it's so different when you're brain dead versus like you're not heart dead?
Sure. No, correct. Yeah.
Is that why they make such a good distinction?
They do. Because if there's not these certain waves in your brain that are showing some sort of conscious pattern, well, there's no reason. You're just basically a vegetable, right? You're not actually a human person in their medical opinions. This enteric nervous system has its own reflex arcs, 100 million different neurons that are there. It's regulating the motility, how the movement of, right, your esophagus, your stomach, your intestines. It's the secretion of the enzymes. It's controlling all of those pieces. Now, sympathetic and parasympathetic also regulate the system, right? They still affect it, but it doesn't need the parasympathetic and the sympathetic in order to work. Does that make sense, my friends? And there we go. We finished the whole page of a study guide. And again, if you look where we are in your textbook now, we're in 15.3, and I kid you not, if you look, it's like 4 or 5 pages, and we're done. You with me? It's good. No, it's a good thing. It's a good thing. All right, so I'm going to stop this here.